Assalamu alaikum. Today the topic of our discussion will be the electrical systems that we use in our building. So let's start first with what is an electricity, because it is just a general term that we use for a variety of phenomena that take place around us, like resulting from the presence and the flow of electric charge from one place to another. The first use of electric supply was established in 1882 by Thomas Edison. Now let's have a brief know-how that how the power is generated and how it is transmitted from the power generators to our homes, to our buildings. So basically, power generation systems are a combination of a potential energy, which is a stored energy, and then we those power generator systems convert that potential energy into a kinetic energy, which on turning into kinetic energy actually creates power, electric power for us that we can use for running motors, for heating purpose, for lighting and other conveniences of our modern life. Now what happens is that how this electrical power, which is generated at the power generator plant, how it is transmitted into bulk from the generating side to our houses. So here is an example. Here is a picture showing that how this phenomena happens, that the potential energy that is stored here in the power plant, now it is converted into kinetic energy, hence it generates electricity. Then from that power plant, that kinetic energy of the electricity, it's transmitted to the transformer. Okay, this steps up the voltage for transmission. The higher the amount of voltage is, the higher the speed of the transmission of electricity. From here it goes to towers like this. These are the transmission lines, and these are meant for carrying the electric charge, the electricity, to a long distance. Then through these kind of transmitters, the electricity is then reached to the neighborhood transformer. Okay, so at this point we up the voltage of the electricity. Why? Because if the electricity is passing through the cables with low voltage, with low speed, that means that there is a lot of loss of electricity while it's traveling from one point to another. But as we increase the voltage, there will be less loss of electricity through these cables, through these transmission lines. So as soon as it reaches the neighborhood transformer here, we step it down. We step down the voltage because we do not need to send it to a longer distance now. From here, from this point, it actually goes to the distribution lines, which actually carry the electricity to the different buildings, to houses, etc. And there are the transformer on poles which further step down the electricity before it enters into our buildings, into our houses. And this is the amount of voltage that we actually require in our houses to turn on the electric kettle or lights or a TV or any kind of machinery. This part here also shows that if we have any kind of solar panels attached to the building, or maybe separately, or if we are generating the electricity through wind power, they are actually connected to the distribution lines over here which carry electricity to the houses. Okay, so the power generation and transmission, that the current is sent through transformers to increase the voltage to push it to the longer distances, and then that electrical charge goes through high voltage transmission lines. So from electricity generated at power plants, it goes to the grid stations. From grid stations, it is reached electricity substations. From there to the transformers, from transformers to the power lines, and then to our houses, the consumers. Okay, so the amount of volts that we receive in residential buildings is 120 or 140 volts. It depends upon that how far the building is from the grid station from this point. Entry in the building. So in urban areas, we usually use electrical cables that are buried under the ground, and they are only brought up to the entry point at ground level or at the basement level. But these are the pictures that are usually they can be seen in the walled city of our areas like in Rawalpindi and in Lahore, and this picture shows somewhat a sophisticated layout of cables in cities like Lahore and Islamabad, etc. Uh, but in first world countries, all of these cables that you can see here, they are actually buried under the ground, and you can just see one pole which is the closest to that building or to that particular area, which becomes the entry point for the electricity to enter into the building. And sometimes these entry points are also hidden. You cannot see them apparently because they terminate at a basement level. So these cables actually terminate in our distribution board, which is also called DB, wherever there's the first convenient position. So distribution board looks like this. You must have seen this kind of distribution boards and maybe in walls of your porch or basement. So what is a distribution board? It is also known as a panel board, and it is a component of an electricity supply system that divides an electrical power feed into subsidiary circuits. And it provides a protective fuse or a kind of circuit breaker for each circuit in common enclosure. So you might have seen that, for example, this is the distribution board of your house, and all the electricity system in your house has been divided into these four circuits. Maybe your drawing room, TV lounge, and dining room has this fuse, this circuit breaker. Your kitchen and toilets have this circuit breaker, or maybe these two circuit breakers are allocated for the ground floor spaces, and these two for the upper floor. So it depends how the electricity system has been divided into your place. So this distribution board will be fitted with a seal box. This is kind of a seal box. This is to prevent the DB, these circuits, from the moisture, that it does not enter into it and it does not destroy the insulation of the service cables like these. And the position that we choose for allocating this distribution board is, it should to be readily accessible, both for the meter reading purpose and for the replacing fuses. Just in case if any circuit breaker or any of these fuse goes off, we can readily replace this. And in some cases, special glass casing is provided so that the meter can be read without entering the premises. That this part in this picture, it is made up of all steel and it's solid, you cannot see through it, but sometimes just we provide at this place glass so that without opening the door we can see whatever reading that we wish to inside the DB box, distribution board. Now the main circuit breaker. So these are also all circuit breakers, but this one is the main circuit breaker. By making it off, we actually put off all of these circuit breakers. So what does the main circuit breaker do? It controls the electricity flow from your two main wires to your hot bus bars. So what is the hot bus bars? This is just a strip, a metallic strip that has been provided here at the back of this main circuit breaker, and this is the point where it collects the electricity that is coming from outside, and then it's again the same point from which the electricity is actually branched out to different circuit breakers inside the house. So as it says, that tripping off this main circuit breaker, it is actually going to disrupt the 240 volts that are coming from the outside electricity before it reaches to the branch breakers. So these circuit breakers, these are also called branch breakers. So another phenomena that takes place in our buildings which actually causes fire is short circuiting. So let's now discuss that what a short circuit is and how does this thing happen. So when we have a part of a wire that is carrying current and it touches another wire, a wire or a part of the circuit, and it changes the electricity path to the one which has less resistance. For example, we have a battery here, and these two cables, blue and red ones, these are attached to this bulb once we are going to on this battery, as in we would allow the flow of electricity to pass through it, this will actually form a circuit. The electricity will come from here till this point. It will on the bulb, switch it on, and then from this point it will go back to the battery. This is how a proper circuit works. Electricity comes from one side and is going to another side to the battery. Now just take an example that we have a faulty wire here in which the insulation is exposed and it touches another wire, like here at this point. This red cable is actually touching the blue cable here at this point. This is going to change the path of circuit. The electricity, instead of going to the bulb, it is actually taking a short path, and from here it is going to this cable, blue one here, and then back to the battery. This type of current flow is actually going to cause shock, and sometimes the sparking also happens because of the excessive amount of heat that has been produced here, and this point is actually going to experience short circuiting, and this will cause fire. So less resistance implies more heat, which causes fire eruption. So to avoid that short circuiting, we actually provide a ground wire, which is also called earthing wire. Earthing wire consists of this yellow and green color, and its purpose is that it directs that excessive electric shock from any short circuiting hot wires into the earth through this copper metal, and it prevents the electric shocks. So ideally all of our buildings should be provided with a ground wire or an earthing wire, but unfortunately we don't make use of this. Now once electricity has reached to the main entrance point of our house, then how does the basic wiring system works in a building? How does we carry it from one point to another point within a building? So wiring in the building either runs on the surface like this, alright, or this is a switch and this is the wiring that is running from this point to another point, and this is like revealed, you can see it, or it is concealed when we are doing the construction of the building, and hence you just see these type of switches and you cannot see the cables running through. Obviously surface wiring is cheaper as compared to the concealed wiring, but the surface wiring has limited use because of the way it appears on our walls. So what are the different types of electrical wiring systems that we use? We use CLEAT wiring, wooden casing and caping wiring, CTS or TRS or PVC sheath wiring, lead sheathed or metal sheath wiring, and then we have conduit wiring. There are additional types of conduit wiring according to the pipe installation, that where we use steel and PVC pipes. They are used for wiring connections and installation. So and then it can be either open conduit type or surface type, or we have a recessed or concealed or underground type of conduits that we use for electrical wiring systems. First of all is the CLEAT wiring system. CLEAT wiring system looks like this. So this system of wiring comprised of an ordinary PVC insulated wires, these cables. They are sometimes sheaths and they are weatherproof cables, and they are braided along, and they are compounded, held on walls or ceilings by means of plastic or wooden ravel plugs like these. Can you see? This is the big one. These are the recessions which actually hold the wiring into their places. So this is the wooden CLEAT and this is the plastic CLEAT. So CLEAT wiring system is a temporary wiring system. Therefore, it is not suitable for the domestic purpose. And in fact, the CLEAT wiring system is kind of an obsolete nowadays. You can just find them in very old buildings. But as the technology is improving, we are trying to avoid using CLEAT wiring systems. So all of these wiring systems have their own advantages and disadvantages. So let's first start what are the advantages and disadvantages of CLEAT wiring. So advantages are that it is simple and cheap wiring system. It is more suitable for temporary use, that is in buildings which are under construction or army camping, like temporary use. The cables and wires of CLEAT wiring systems are open in the air. So if there is any fault in the cables, it can be easily seen and we can readily repair it at the spot. And the inspection of these type of cables is very easy and simple. But all of these advantages also lead to the disadvantages, that obviously appearance is not so good. CLEAT wiring cannot be used for the permanent purpose because these wires can sag after some time. And in this wiring system, the cables and wirings are open in the air. Therefore, any kind of oil or steam or humidity, rain, chemicals, etc., anything, they can affect the cable wires. They can damage it actually. And because of that damage, there is a lot more risk of the electric shock, the short circuiting, and hence the fire. Also, the CLEAT wiring system is not long lasting. It's not that reliable and a sustainable wiring system. The next wiring system is batten wiring. This is an old wiring system. Uh, the process is that there is a single core or maybe a double core or three core TRS cables. These are the type of cables that we usually use for the electricity transmission within our houses from one point to another. And these cables, these pre-core TRS cables with a circular oval shaped cables, they are used in this kind of wiring. So these TRS cables are often chemical proof and waterproof and steam proof, but they are slightly affected if there is any kind of a lubricating oil nearby. These wires are actually been painted white just in order to make them disappear with the white wall actually. But there is actually a wooden batten here on which all of these cables are joined together, and they are pinned together by using these little brass link clips, or they're also called buckle clips. So these buckle clips actually fasten or fix these wires, TRS cables, onto the wooden batten. So this wooden batten is actually a well seasoned and straight teak wood. The thickness of this wooden batten is at least 10 mm, and these clips, which are actually fastening the cables onto the wooden batten, the interval between them is 10 centimeter for the horizontal runs and 15 centimeter for the vertical runs. Like for the vertical, the distance between this clip and this clip is actually 15 centimeter, which is the vertical one, and the interval is 10 centimeter when we have to make it the horizontal run. Although these ones are very closely pinned together, it's not 10 centimeter. But yeah, the advantages and disadvantages of batten wiring is that, first of all, advantages: wiring is obviously, installation is simple and easy. It is cheap as compared to the other electrical wiring systems. Repairing is easy, similar to the CLEAT wiring system, but they are slightly more stronger and long lasting than CLEAT wiring system, and customization can easily be done in this wiring system. Disadvantages: they cannot be installed where there is a lot of humidity or chemical effects or open and outdoor areas. Because of being visible on the wall, they have a high risk of fire, because all of these things can actually damage the insulation within that cable. So these are not safe from external wear and tear and weather effects, because these wires are openly visible to heat, dust, steam, and smoke. And we cannot use heavy wiring when we are using batten wiring system. So next is casing and capping wiring. Casing and capping wiring system was famous wiring system in the past, but it is actually obsolete nowadays because of the conduit and sheathed wiring system. The cables used in this kind of wiring are PVC or any other approved insulated cables, and these cables are then carried out through the wooden casing enclosures. So these are actually the wooden casing enclosures, these ones, but they are actually painted white according to the color of the wall. and their joints are like this. See, and these are the cable wires that coming out of it. So the casing is made up of a strip of wood with parallel grooves that are cut lengthwise so as to accommodate the PVC cables, like these. So basically, this part is one thing, and this part actually slides over this lower part. Now the advantages and disadvantages of casing and capping wiring. Advantages are that it is a cheap wiring system as compared to the sheath and conduit wiring system. It is strong and long-lasting wiring system. The customization can be easily done, and the wooden conduit actually keeps the cable safe from the oil, steam, smoke, rain, etc. And there is no risk of electric shock due to covered wires and cables in casing and capping. Disadvantages are that there is still a high risk of fire in casing and capping wiring system, and the system is not suitable where we have acidic, alkalis, or humidity conditions. Then whenever we have to repair this wiring system, we need more cost because of the need of more material which will be required, and white ants may damage the casing and capping of wood. Now let's come to the most latest one, conduit wiring. This is an electrical conduit. This thing is called conduit. It's a tube like structure which is used to protect the electrical wiring in a building or a structure. And there are two types of conduit wiring according to the pipe installation. The first one is surface conduit wiring, and the other one is concealed conduit wiring. The name actually, both of these names actually suggest how that conduit wiring will be. So the surface conduit wiring, this wiring is the one which is actually installed on roof or wall, on the surface of roof or wall. So these are the conduits, and these are usually non-metallic conduits, PVC, like this, plastic ones. And here they have shown the metallic conduit wiring, which is made up of steel, but obviously the PVC is much cheaper as compared to the steel. But at the same time, the steel conduits have long lasting and more sustainability as compared to the PVC non-metallic conduit. So what happens is, in this wiring method, they make holes on the surface of the wall, right, on equal distances, and the conduit is installed then with the help of the ravel plugs. Whereas in concealed conduit wiring, the conduits are actually hidden inside the wall slots with the help of plastering. In other words, the electrical wiring system inside wall or roof or floor, we install it with the help of plastic or metallic piping, which we call concealed conduit. And this type of concealed conduit wiring is the most popular, beautiful, stronger and common electrical wiring system nowadays, because all you see on the wall or on the roof or floor is this switch. That's all. Nothing like this wiring, etc. Nothing is visible to us. Therefore, it actually gives us more area on the wall or on the roof to play aesthetic wise. So as already discussed, that there are two types of conduits. One is the metallic conduit and other one is the non-metallic conduit. Metallic conduit is made out of steel, and which is strong, but it is costly at the same time. And non-metallic conduit is a solid PVC conduit, like these ones, and they are more flexible and easy to bend as compared to the steel conduits. Advantages of conduit wiring system. First of all, it is the safest wiring system so far, especially when it's the concealed conduit wiring. Appearance is very beautiful, and there is no risk of mechanical wear and tear in case of metallic pipes. Customization can easily be done according to the future needs. So you might have seen that in the concealed conduit wiring systems, you always get the provision of maybe the optical cable, the cable for the TV connection, cable for the extra light connection in the conduit, and then we conceal it, we plaster it if we don't use it. But just in case in future, if we get the need of using those wires, it is easy for us to install a fixture over there, because all that we need to do is take off that concealed part of the conduit, pull out the required cable, and fix it with the appliance, whichever we wish to turn on. So these conduit wiring systems, we can also use them in humidity and in areas where it's smoky or they have the chemical effect, and this is the most reliable and popular wiring system nowadays. Disadvantages: obviously it's a very expensive wiring system because of the PVC and metallic pipes and the additional earthing that we have to do with the metallic pipes, T's and elbows, etc. And it's very hard to find the defect in the wiring once the conduits are concealed with plaster and then whitewashed. Then it gets difficult for us to find the defect at where it is. Installation is not that easy and simple, and there is a still risk of electric shock present, especially in the case of metallic pipes which do not have proper earthing and grounding system. So short circuiting is common in case of these steel conduit wiring systems, and these are very complicated to manage additional connection in the future. Okay, now let's talk about the electric installations that we need to have in our buildings. So whenever we have to install some electric appliances in a building, we actually require a necessary design, and we have to plan taking into consideration the whole requirements which will be necessary for the activities that would be carrying out in that building. And for that we actually follow a number of steps, and we follow these steps one by one, and then we achieve our goal of electric installation in a building. So first of all, we start with the planning and designing. Then we do the layout of working drawings. Then we give an application to the electric supply company to grant us an estimated load supply and requirement of transformer or a substation. We actually lay out the conduit wiring system for the underground supply lines before we do the concreting and completing the plinth work. Then after laying the conduits in the plinth work, we do the conduits in the slabs and beam reinforcements, just in case we have to provide a fixing hook for the fans, or maybe a box for the chandelier. So all of these things are all provided in the slab reinforcement for main supply to consumer units here rooms. So we should know beforehand, before the construction of slabs and beam reinforcements, that where do we need to provide our electric installations, where do we have to provide the fans, where do we have to provide the wall lamps or roof chandeliers, or where the AC would be provided, because we have to give the wiring cables according to the appliance on that wall or on that roof. After that, we do the physical marking of layout of wiring in all rooms. Then we provide and lay the complete wiring. The next step is that we fix all the fittings and fixtures and complete all the electrical installations. Once all the electrical installations have been installed, we do an installation test that all of these fixtures are actually working properly. Then we are actually provided by a consumer meters, the application that we have given to the electric supply company for granting us a substation or a transformer. They actually, if it's a small house, a small building, and there's already a transformer or substation present over there, then the next step is that we are provided with the consumer meters. Then the last point, which has not actually been carried out here in Pakistan, but and abroad, this is very common that all of the electrical installations are actually checked by an authorized officer of electrical supply company before they pass and seal the meter for us. Now let's talk about a bit in detail that what do we do in a design and planning stage of an electrical installations in the building. Okay, so the design and planning of an electrical installation is actually governed by the type of the use of the building and the requirement of the consumer. Therefore, it is very essential that we first consult a licensed electrical contractor at the planning stage who is going to provide us the planning for the electrical installations which are safe to use and also efficient in use, and they are adequate for their intended purpose. For designing the layout of electrical installations for a specific requirement of power use, it is also essential that at the planning stage the architect sits in consultation with the structural engineer, with the electrical engineer, and also with the developer to decide about the following things. So what are those following things? Number one is what are the needs of accommodation for making provision of substation, or do we need, where should we have a meter room or switch room, where should be the services cable duct, where should be the rising main and cables, the DBs, the circuit boards, and where should be the opening and traces required in the floors and walls for the intending electrical installations. Then what is the total load requirements, that how many lights the building require, how many fans, how many power sockets it requires, etc. Then we anticipate that in future, if there is a increase in power consumption, what will be the requirement of electric supply company, including location and distance of main supply connection point. Then we discuss that what will be the layout of the wiring installations, whether it is going to be open conduit or a concealed conduit wiring system. So after collecting all the necessary information and suggestions from the other consultants, it is the duty of the architect who should prepare a detailed working drawing of a complete electrical installation in consultation with the licensed electrical contractor. So that is all about the requirements regarding the electrical installations within a building.